Okay, so we are going to start with exponents and radicals. With this lesson, it's a lot of stuff that you've seen before or done before. So it's not anything that's new, or it shouldn't be new to you. Okay, so if we look at the first part, it goes over your rules of exponents. You need to remember that when you're multiplying two terms that have the same base, you're adding the exponents. If you're dividing two terms with the same base, you're subtracting the exponents, keeping the base. If you have a term that's raised to a negative power, in order to make that power positive, you take the reciprocal of the term that it's attached to, and it turns the exponent positive. Anything raised to the power of 0 is 1. If you have something in parentheses and it's being raised to that power, a power is then applied to both terms inside the parentheses, unless there's an operation in between the two terms in there. If you have a number raised to a power, then that is raised to a power. You are multiplying those powers. A fraction raised to a power, you pull that power to both the numerator and denominator and apply it to both terms. And the absolute value raised to a power is the same thing as taking that absolute value of the term, then raising it to the power. Okay, so we're going to go through some examples. Your notes may look a little different than mine. I'm not sure. Ms. Meadows and I looked at this today since we're both teaching this class and kind of pulled out some unnecessary examples or pulled out unnecessary wording that we could just tell you instead of you having to read through it all. So there will be some differences between your notes most likely and these. I'm not sure if I posted these exact ones to Canvas or not. So just try to follow along as best as you can. The examples are all the same, so we will be doing all of those. We're going to start with example A here. We're just using the properties of exponents to simplify these expressions. So for A, we have negative 3ab to the 4th power times 4ab to the negative 3rd power. With this, you are going to multiply your coefficients so that negative 3 gets multiplied by the 4. You then have A to the 1st plus the 1st, since they're both to the 1st power. And then your B gets multiplied by each other. So that's the 4th power plus the negative 3rd power. We simplify our powers. We simplify that multiplication. The negative 3 times 4 is negative 12. You will have A to the 2nd, B to the 1st. Now remember, you do not need to write that 1 as that exponent on that B, so we can just write the negative 12A squared B for our answer. For B, we have 2xy squared raised to the 3rd power. So this power of 3 is going to go apply to the y squared, the x, as well as the 2. So this is going to be 2 cubed times x cubed times y squared cubed. So the 2 cubed gives us 8. The x cubed gives us x cubed. And the y squared raised to the 3rd power is going to be y squared times the 3rd, which is going to give us a total of 8x cubed y to the 6th. For C, we have 3a times negative 4a squared raised to the power of 0. Remember, anything raised to the power of 0 is 1. So this negative 4a squared raised to the power of 0 is just going to turn into 1. So we have 3a times 1. So 3a times 1 is just 3a. Our solution is 3a. for D, we have 5x cubed over y, all raised to the second power. So we're going to raise that numerator of that 5x cubed to the second power, as well as the denominator y to the second power. Remember on that top, we have 5 to the second power and x cubed to the second power. So we're going to apply this square to both the 5 and the x cubed. So this is going to be 5 squared times x cubed squared. And then that y to the second power is just y squared. The 5 squared gives us 25. The x cubed raised to the second power is x to the 6th. And then y squared stays y to the second. You cannot simplify anything else further with that one, so that is your solution. For our next part of our lesson, we're going to be going over radicals and their properties. So you need to remember that you cannot take a positive, even number root of a negative number. So you cannot have the square root of a negative number. You cannot have the fourth root of a negative number, and so on. Any root of 0 is 0. And then if you're dealing with odd roots, so 3, 5, 7, those roots, they can be a negative and your answer is going to just be negative. Okay. With these, you also can turn your radicals into expressions that have exponents. So your index, so that little number that's attached to the radical, will always be your denominator of your fraction in that exponent. So in this case, for the first property, the nth root of a to the power of m, it's the same thing as saying the third root of 8 squared. So the 2 is your numerator and the 3 would be your denominator if you were to write this as 8 to the power of 2/3. Okay, you could also simplify it by doing the cube root of 8 and then squaring your answer. So the term that is being raised to the power, the term underneath the radical, that power can always be put outside the radical. With the rest of these, you're following the same rules. If you have a fraction underneath the radical, it means that you're taking the square root or the whatever root of the numerator and the denominator. And then you have to set your denominator to where it's not equal to 0 because we cannot have 0 in the denominator of a fraction. If we look at our next example, we're just simplifying these expressions. So A, we have the square root of 8 times the square root of 2. You need to remember, if you've had me, we've gone over this. If you haven't had me, you may not have seen it. But you can always find the root of anything by finding the prime factorization of that number. So let's say you don't know what the square root of 8 is. You can take the square root of 8 by finding the prime factorization of it. 8 is 2 and 4. The 4 is 2 and 2. Because we have an invisible index on this radical and we're taking the square root, we're looking for sets of 2. So this is a set of 2. We pull one of those 2's out to represent that set, and whatever's left over stays underneath the square root. So that's 2 square root 2 times the square root of 2. Now, this is like we have like terms. Because the square root of 2 is the same, and that's your base with these two numbers, we can multiply. The base is going to stay the square root of 2 times the square root of 2, which would be 2 times 2 underneath there. And then that 2 out front gets multiplied by the invisible 1 that's in front of the square root of 2 that comes second. So that's just 2. When we find the square root, we're looking for pairs, so sets of 2. We have a set of 2 here, so we don't need to do anything else other than bring that 2 out. And 2 times 2 is 4. So we find the square root of that 8. We get 2 square root 2. We then multiply. We're going to multiply the radicals together as we multiply the so-called coefficients together. The 2 times 1 is 2. The square root of 2 times 2 is just 2. You could have done the square root of 4, which is also 2, and then you just multiply. So 2 times 2 is 4, and that would be our solution. Example B here is probably one of the easiest examples you'll have. Whenever you have a number underneath a radical, where that index of the radical is the same as the power that that number is raised to, the power and the index cancel each other out. So in this case, the cube root of 5 cubed, because the index is the same as the power, they cancel each other out, and the only thing you're left with is 5. You got to think about this. This is the same thing as saying the cube root of 5 cubed. Well, 5 cubed is still the cube root of 5 times 5 times 5. If we're finding groups of 3 to cancel out that radical, we have a group of 3 5s. So that radical would cancel out, and it would just be 5. For C, we have the cube root of x cubed, same exact thing. Our index is the same exact as our power, so they cancel each other out, and we're just left with that x. For D, we have the 6th root of y to the 6th power. So this 6 cancels out the exponent, so we just have y. If we look at example 10a, we're just simplifying these radicals so we can do the same thing that we did with that square root of 8. For a, we have the cube root of 24. So we're going to find the prime factorization of 24 since we don't know off the top of our head what the cube root of 24 is. 24 is 3 and 8. 8 is 2 and 4. The 4 is 2 and 2. We're looking for groups of 3. We have 3 2's. So we're going to pull 1, 2 out. That cube root of 3 is going to be left over. So you have to remember with these, I saw a lot in the past when we did these, that if you had a number left over, you would just put it underneath a radical sign without that index. Whatever index you start with, you have to include in your answer. So if this 3 was put underneath, let's say the square root, instead of the cube root, it would actually be wrong. So you have to be careful with that, and you have to remember or remind yourself, whatever index I start with, I have to include if I have a radical left over. For B, we have the 4th root of 48. Well, 48 is 4 and 12. The 4 is 2 and 2. The 12 is 2 and 6. And the 6 is 2 and 3. We're looking for groups of 4. Now we could rewrite this as the 4th root of 2 times 2 times 2 times 2 times 3, since that's the prime factorization of 48. If we're looking for groups of 4, we're pairing up that 2 as a group of 4. Since we have that group of 4, we're going to pull that 2 out. The 3 is left over, so it's going to stay underneath the 4th root. And your answer will be 2 4th root 3. For C, we have the square root of 75x cubed. If you wanted to separate this into 2 square roots, you could. This is the same exact thing as saying the square root of 75 times the square root of x cubed. If we find the prime factorization of 75, we have 3 and 25. And the 25 is 5 and 5. We're looking for a group of 2. So these two 5s pair up to be 5. That 3 is left over, so it stays underneath the radical. From here, that x cubed is the same thing as saying x times x times x. So if we're taking the square root of that, we're looking for a group of 2. So that one x would come out to represent both 2's underneath, and then you are left with that x. From here, we just multiply. So whatever's on the outside of that radical multiply together, and whatever's on the inside of that radical, as long as the index is the same, multiplies together. So we would do the 5 times x, keep the square root, do the 3 times x underneath the square root. 5 times x is 5x, and 3 times x is 3x. So that's 5x square root 3x. We could do the same thing with D and use the same method, or we can do it a little bit different. So sometimes I like using the first way that we just did this in example C because it's not as long and drawn out. With D, the way that I'm going to do this is I'm going to find the prime factorization of the 24, find the prime factorization of the a to the 4th, and put the prime factorization of both underneath that cube root. So if I find the prime factorization of 24, I know the 24 is 4 and 6, the 4 is 2 and 2, the 6 is 2 and 3. The a to the 4th is just a times itself 4 times. So this is the same exact thing as saying the cube root of 2 times 2 times 2 times 3 times a times a times a times a. Now my index tells me the amount of numbers I need to group together. In this case, it's that 3. So I need 3 2's, 3 3's, or 3 a's in order to pull 1 out. I have 3 2's, so that pair, that one of them comes out to represent it. I only have 1 3, so I'm going to leave that alone. The a's, I have more than 1. I do have a group of 3, so I'm going to pull one of those a's out as well. Anything that is not included in the circle, I'm going to leave underneath that radical. Remember, my index is 3, so I'm going to keep that 3 as my index, and then write down that 3 times a underneath that radical. From here, I'm just going to simplify my multiplication, and then I'm done. So 2 times a on the outside is 2a. I keep my cube root of 3 times a, which is 3a. So that's just 2a cube root 3a. when I say that it's not as long and drawn out, the first way that we did this with C is not as long as drawn out as D. It just means that sometimes you're gonna have a term underneath that radical like a to the 8th power or a to the 10th power. And when that's the case, that's a lot of a's to write out, and you're not necessarily gonna have enough space in order to do that. So I don't care doing it that way. So there's also another way to do it, which you might have done in the past as well. So with D or even with C, if your index is a specific number, like with D, it's 3, and you have a number raised to a power or a variable raised to a power, you can divide that power by the index in order to simplify it. So in D's case, you have a to the 4th power. The 4th power divided by the 3rd, which is the index, would leave you with 1 and 1 left over. Literally give yourself a fraction of it. So if you're a to the 4th, a to the 3rd, or sorry, a to the 4th, and then your index is the 3rd, that's 4 over a, or 4 over 3. Turn that into a mixed number. Well, that's going to be a to the 1 and 1/3. So guess what? This 1 represents how many a's you pull out. The 3 tells you the index. And then the 1, that's your numerator of that mixed number, tells you how many is left over underneath the radical. So that's just a to the 1st. So that gives you also another way of doing it. So that way, if you have a larger number that's your exponent on that variable, you don't have to write it out like I just did when we did this example. For 10, we have 10e, we have the 4th root of 5x to the 4th power. So this is literally telling you, you could realize this, that your index and your power is the same, so they cancel out and it's just 5x. Or you can say this is the same thing as saying the 4th root of 5x to the 4th power. Well, that's 5x times 5x times 5x times 5x. You need a group of 4 to pull 1 out. Your group of 4 is there, so that's just 5x. So same exact thing, same exact answer, just a different way of doing it. With our next part of examples, we're combining radicals. So with these, you want to simplify these radicals first before you can combine anything. So for A, we have 2 square root 48 minus 3 square root 27. The whole idea when you are doing these combinations is if your operation is if your operation is addition or subtraction, in order for you to be able to combine your radicals, it's like combining like terms. They have to have the same term underneath the radical with the same index in order for you to combine them. So for A, we have 2 square root 48. The square root of 48 we need to simplify. The 48 is 4 and 12. The 12 is 4 and 3. We're taking the square root, so we need a pair. That's a 4, gives us a pair. So that's 2 times 4 square root 3. Then you have that minus 3 square root 27. The square root of 27 is 3 and 9. 9 is 3 and 3. Those 3's would pair up, so that's going to leave you with 3 square root 3. Simplify the multiplication here. Do the 2 times 4 and the negative 3 times 3. 2 times 4 gives us 8 square root 3. And then the negative 3 times 3 gives us a negative 9 square root 3. Now ask yourself, do I have the same number or the same terms underneath my radical, and is my index the same for both? Your index is the same, you're taking the square root for both, and both of them are the square root of 3. So keep the square root of 3 and combine what's in front of them. So you're doing the 8 minus 9, and you're keeping the square root of 3. 8 minus 9 is -1, so that is just negative square root 3 for your answer. For B, we have the cube root of 16x minus the cube root of 54x to the 4th. So with the cube root of 16x, I'm going to find the prime factorization of 16. That's 4 and 4. The 4 is 2 and 2. I'm looking for a 3, so that's 2. That comes out. Then I have the 2 left over and the x left over. So that's 2 cube root 2x. Next, I have that minus, then the cube root of 54x to the 4th power. The 54 is 6 and 9. The 6 is 2 and 3. The 9 is 3 and 3. So I'm, again, looking for a group of 3. So that's a 3. I have x to the 4th as well. So if I take 3 from that, I'm going to have 1 left over. We're not subtracting these, we're dividing them. So this would give me 1 and 1/3. So again, I would take 1x out and leave 1 underneath the radical. So I'm going to have a 2x underneath that cube root. From here, my radicals are the same. So I'm going to subtract the so-called coefficient of them. Can I do that? I have a 2 and I have a negative 3x. Are they like terms? No, so you cannot combine them. Once you get to this point, you would be done. So again, you have to remember your rules with combining like terms when you're doing this. So in this case, because that first radical doesn't have an x attached to the 2, you cannot combine the 2 and the negative 3x with subtraction. So you'd have to leave it just like this. The next part of your lesson deals with rationalizing denominators. This happens when you have a denominator that has a radical in it. In order for you to simplify the expression, you have to take into consideration the index and multiply the top and the bottom of that fraction by what the bottom is. So for this one, you have 5 over 2 square root 3. That 2 square root 3, that radical of the 3 needs to be simplified. You need to rationalize it. You can't keep this, okay? So that radical 3, you are going to multiply the top and the bottom by your denominator. So that's 2 square root 3, 2 square root 3. From here, simplify. The 5 times 2 gives us 10. You keep the square root of 3 there. And then on the bottom, you have 2 times 2, which is the 4. And then the square root of 3 times the square root of 3, you can leave. Or you can say it's 9 and take the square root of that. So this would give you 10 square root 3 over 4 times 3. Now you can simplify the 10 and the 4 first before you do the multiplication. It's totally fine. If not, you would just have 10 over 12 and you would simplify that. So the 10 is going to turn into a 5. The 4 turns into a 2. So this would be 5 square root 3 over 2 times 3, which is 6. For B, we have 2 over the cube root of 5. Because your index is 3 here, you can't just multiply the cube root of 5 on the top and the bottom. You have to follow that index. So because it's a 3, you're going to multiply a total of 3 times with that cube root of 5 on the bottom. So we're going to do this cube root of 5 times the cube root of 5 on the bottom. Now you have 3, which will cancel out that cube root. And you're going to do the same thing on the top. So you did it 2 more times on the bottom. You're going to do it 2 more times on the top. When you write this, you're going to have 2 times the cube root of 5 times 5, because if the radical is the same, you can just multiply what's underneath them. And then on the bottom, you're going to have the cube root of 5 cubed. And we said, what happens with your index and your power being the same? They cancel out. So these 2 would cancel. On the top, you're going to have 2 cube root 25. On the bottom, you're just going to have 5.
Ms. Glick,
Yes.
why did you multiply the denominator by both sides twice?
Because your index is 3. So when you rationalize that denominator, you want a total of the multiplication of that term 3 times.
Okay, thank you.
You're welcome. So whenever your index is something different other than the square root of something, so let's say you had the 4th root, you would multiply the denominator by itself 4 times total. If it was the 7th root, you would multiply the denominator by itself 7 times total. And then however many more you added on to multiply on the bottom, you would do the same to the top.
Ms. Cliff, could you go back to example 11, please?
Which one?
That
The
one.
A.
Oh, wait. Oh, no, 12. Sorry. Go down. 5 over 2, 3. Thank you.
You're welcome. With example 14, we're rationalizing the numerator. What that means is that you are taking the conjugate of the numerator and multiplying it by both the top and the bottom. The conjugate just means the same the same expression with the opposite sign. Okay, so with the top here, you have this square root 5 minus the square root of 7. You are going to multiply the top and the bottom of this fraction by the opposite of that with the middle, just the middle, not the front and the back term, just the middle. So we are going to multiply, we're going to put parentheses around this, we're going to multiply it by 5, the square root of 5 plus the square root of 7. If we did it on the top, we have to do it on the bottom, just like when we do it on the bottom, we have to do it on the top. So we have the square root of 5 plus the square root of 7 on the bottom as well. When we do this, we are going to FOIL the top. So first, inner, outer, last. You're going to do the square root of 5 times the square root of 5. That's going to give you square root of 5 times 5. Then you have the square root of 5 times the square root of 7. So that's the square root of 5 times 7. Then you have a negative square root 7 times the square root of 5. So that's the square root of 5 times 7. Then you have the negative square root 7 times the negative, or the positive square root 7, which gives you a negative square root 7 times 7. On the bottom, you're just going to distribute that 2. So you're going to do 2 times the square root of 5 and 2 times the square root of 7. From here, you're going to realize that on the top, those middle terms have opposite signs, but the same numbers underneath the radicals that are being multiplied, so they cancel each other out. The first radical, you have 5 times 5, that's a pair, so that's just 5. Your sign in front of the square root of 7 times 7 is negative. Again, that's a pair, so that's just 7. You're going to keep this all over 2 square root 5 plus 2 square root 7. Now, if you wanted to, you could factor the bottom. Since they both have a 2 in front of the square root 5 and the square root 7, you could factor out a 2 and it would just be 2 times the square root of 5 plus the square root of 7. You can do that as well. The reason why I say that is because when you do 5 minus 7, that's going to give you a negative 2. If you factored the bottom, this would be 2 times the square root of 5 plus the square root of 7. Now, could you have just kept it like that from the beginning? Yes, you could have. From here, these 2's would cancel out, so you would just have negative 1 over the square root of 5 plus the square root of 7. If you realize with this example, it tells you to rationalize the numerator, not the denominator. So with the examples that we did before this, you were rationalizing the denominator. That's why we did not have a fraction with a denominator that had a radical. For this one, though, it tells you to rationalize the numerator, so it's okay to have the radical in the denominator. Will you always have that? No, you won't. You have to pay attention to your directions with these. With your rest, like these pages, it just gives you an explanation of what I'm going to quickly go over right now because we don't have that much time left. With this, it tells you that you cannot have a negative exponent. To turn the negative exponent into a positive, you take the reciprocal of the term that it's attached to. So it's going to be 1 over a negative 32 raised to the 4/5 power. From here, you're going to apply that 4/5 for the power. The 4 is going to stay on the negative 32. The 5 becomes your index. So this is going to be 1 over the 5th root of negative 32 to the 4th power. Now you can simplify this. I'm going to take this off to the side and find the prime factorization of it. 32 is 4 and 8. The 4 is 2 and 2. 8 is 2 and 4. 4 is 2 and 2. You're looking for 5. So 1, 2, 3, 4, 5. It's got a negative. It's going to stay negative. So this is going to be 1 over a negative 2 to the 4th power. Negative 2 to the 4th power is 16. So that's just 1 over 16. For B, we have negative 5x to the 5 over 3 times 3x, the negative 3/4. So this first one, I'm going to simplify. I'm going to take the cube root of 5x to the 5th power. And then I'm going to multiply that by the negative, which I'm going to turn into a positive 1 over 3x to the 3/4 power. So it's going to give me the 4th root of 3x cubed. So I'm going to just put this on top, the cube root of 5x to the 5th power over the 4th root of 3x cubed. Now, you wouldn't be able to simplify this any further. So it would actually, hold on. This is in parentheses. This is in parentheses. This is in parentheses. Your completed notes for this will be posted. Obviously, your class is over, so you are free to go. Your completed notes for this will be posted. Your video will be posted as well today. If you have any questions, please email me. Your practice for this is due Monday. So have a good weekend, everyone.
Bye, Ms. Glick.